Okay, we're going to talk about 3.5, graphing linear equations in slope-intercept form. So the first thing we have to review is what is slope. Okay, so slope, remember, is rise over run, also known as delta y over delta x. That little delta sign is a triangle with like a thick left-hand side there, left leg. Which also means your change in y or your change in x. And we call that in a formula y2 minus y1 over x2 minus x1. Okay, and so let's get rid of that y there. Okay, more importantly for this lesson, we call slope m. Okay, and that's our abbreviation for it. The y-intercept is where a graph crosses the y-axis. Okay, so if we think of it in pictorial display here, if I have a line where that line crosses the y-axis, that's called the y-intercept. Okay, and the y-intercept always has a value of 0 for x. So maybe this point right here is at 5 on the y-axis. We'd have an ordered pair 0, 5. Okay, so it's where it crosses the y-axis. It's also when x equals 0. Okay, more importantly for this lesson, we call the y-intercept b. Okay, and usually it's a lowercase b. So maybe we'll go that route versus the other b there. Okay. All right. So if we're dealing with slope-intercept form, well, slope-intercept form is y equals mx plus b. Now the key piece here is understanding that m and b are actual values of, let me change colors here. Okay, m and b are actual values of m and b that we just talked about. Okay, the y, the equals, the x, and the plus, those all could stay the same, but m and b become numeric values in this, and actually I usually include the plus with that. We're going to see that here in a few minutes. All right, so kind of looking through this. Some other important pieces of information is to know what type of slope you're dealing with. So if you're looking at an equation, so actually, you know what, if I have a line, think of it this way, if I have a line increasing from left to right, in fact, let's just get rid of the axes there. If I have a line increasing from left to right, like you're reading a book, or let's say you're a person and you're on this line and you're walking from left to right. If you are walking uphill, that is called positive slope. Negative slope would be, let's say you have a line and it's falling from left to right. So once again, you're on a line and this time you're walking from left to right, just kind of like reading a book, right? You're walking from left to right and you're going down. That's negative slope. So we always read our lines like we read our books, from left to right. Undefined slope means you have a line that is straight vertical. Okay. In other words, if I had a point up here and a point up here, notice I don't have any run to it. I only have rise. Okay. So my rise would be some number over my run, which would be 0. So let's think of that as rise over run. Well, anytime you divide something by 0, you get what's called undefined slope. All right. And then 0 slope is actually, oops, let's get rid of that there. 0 slope is actually when you have a line, and it's a flat line, it's a horizontal line. So kind of relating to what we just talked about, if you think of rise and run again, you have no rise this time. However, you have some run. We can have any number down there. Okay, so in this case, we'd have 0 over a number, which would mean we'd have 0, a slope of 0. Okay, what I like to do when I'm thinking of this, I like to think of, well, where is my 0? Is it under the fraction bar or is it over the fraction bar? If it's over the fraction bar, my answer is 0. Notice 0 and O kind of look the same over. And then if it's under the fraction bar, my slope is undefined. Actually, it's not undefined, it's undefined, right? Okay. But we can think of it as like undefined, okay? If it's under that fraction bar. All right. Just kind of a trick to remember those there. Okay. Well, let's say if we want to find a slope and we have a picture. So if you're reading your graph from left to right, if I start at my left, first point on my left, and I look at my slope, how much I'm rising and running, and let's go ahead and switch my pointer here. Call it a different color here. I'm rising up 1, and I'm running over 2. So rise over run is 1 rise over 2. So my slope is 1/2. So m equals 1/2. On this one, m equals, once again, rise over run. And so I look at how much I rise. Well, notice from left to right, I'm not actually rising, I'm dropping. So I'm dropping down 2, so we'll write that as -2, but we're still going to the right 2. So I rise -2, I run 2. Well, -2 over 2 is 1. So I have a slope of 1. Actually, I'm sorry, it's a slope of -1. Which also means like -1 could be -1 over 1, which really means I could go down 1 and over 1, and I'd hit my line again. So, okay. Well, let's look at this one. Notice, oops, sorry about that. This one, we start here, and we go down 2, and we don't run at all. So our slope, if we think of it as rise over run again, let's fix this up here. Rise over run, down 2, and over 0. Well, remember that 0 is under the fraction bar, so it's undefined. It's a vertical line there. And the last one, the slope is rise over run again. And I don't actually have any points highlighted here, so let's just pick 2. So let's say that one and maybe that one. So I rise, well, I don't actually rise at all, but I run 3 based on what I put there. So I rise 0, run 3, well, my 0 is over the fraction bar. Okay, so it is a slope of 0. All right, so that's finding slope using a graph or a picture. Now let's go ahead and find the slope using a table. Remember, slope means change in y over change in x, also known as delta y, delta x. Okay, and so what I'm going to look for is just look at my change in x and my change in y. So my change in x, well, on this side it looks like I go up 1 every time. For my y, it looks like I'm going up 3 and, excuse me, not 3, but 4 and 4 and 4. So it looks like I go up 4 each time. So my rise, or actually let's call this change in y and change in x. My change in y is 4. My change in x is 1. My slope then is 4. All right, let's switch colors here. And okay, and so on this one, we're going up 1 again on x. A lot of times x will just increase by 1. And on y this time, we're actually decreasing by 2 by 2 by 2. Okay, so my change in y over change in x, well, I'm going down 2 on y, I'm going up 1 on x. So -2 over 1 is -2. Slope of -2. All right. Well, let me switch it up again here. This one, we're going to increase by 1 on x again. But on y, we're actually adding 0 every time. We're not changing at all. So my change in y over change in x, well, my change in y is 0. My change in x is 1. anything, 0 divided by anything is 0, or you think 0 is over the fraction bar, that's a slope of 0. And picture-wise, that would be y is always 5. So you'd have a line crossing the y-axis at 5. You'd have that horizontal line with a 0 slope. On this one here, my last one, I have, let me switch it up again. Okay, it looks like we're increasing by nothing on x this time. But on y, it looks like we're increasing 3 each time. Yep, continues that. So my change in y over change in x is 3 over 0. Notice the 0 is under the fraction bar, so it is undefined. Undefined there. All right. So that's using a table. Now, the one thing that we haven't done, there's kind of a special case here, or a different look. So sometimes we did looks where x always increased by the same, but let's say x this time, well, it increases by 3, and then by 2, and then by 5. Notice we don't have a constant x increase. Then we go over to y. Actually, you know what, let me fix this up here. Okay, then we go over to y, and we increase by 21, by 14, and then by 35. So notice it doesn't have a constant rate of change in terms of going up by the same amount for x or up by the same amount for y when we look at it in this format. But if we're looking at change in y over change in x, or delta y over delta x, really we're just looking at these individuals. So delta y 21 over delta x of 3. When y changed by 21, x changed by 3. Or when y changed by 14, x changed by 2. So y changed by 14, x changed by 2. Or when y changed by 35, x changed by 5. Now when you start looking at it like that, notice, well, 21 divided by 3 is 7. 14 divided by 2 is 7. 35 divided by 5 is 7. So our rate of change is actually the same. It has a slope of 7. So you could always just compare the individual rates of change for each variable, or each data point. So from 5 to 26, and then its corresponding x value 1 to 4. All right. Well, you can also find slope using 2 points, okay? And that's the last one we'll look at before we actually start graphing or looking at equations and finding slope and y-intercepts in them. So finding slope, remember slope is equal to y2 minus y1 over x2 minus x1. That's a way to find the change in y over change in x. I like to think of it as having 4 different places that I'm looking at. Okay, so y2, y1, x2, and x1. Okay, and so on this first one, I'm just going to quickly draw a picture. I don't want you to draw pictures every time, but just so you know what we're looking at here. So when I say I'm at negative 4, 7, okay. All right, so negative 4, 7, so right there. And then negative 6, negative 4. Negative 6, and 1, 2, 3, 4. All right. Oops. And so what this is saying is, the point's going to erase again. So what this is saying is, how much does your x value change in this direction? Okay. And how much do your y value change in that direction? So, or another way to think about it, if you label these points negative 6, negative 4, and negative 4, 7, how far am I traveling from negative 6 to negative 4 on x, which in that case from negative 6 to negative 4 I've traveled 2, and And how much am I traveling from -4 to 7 on y? So from -4 to 7 on y. Well, -4 to 0 is 4, and then 7 more is 11. Okay, so I could say my rise is 11, my run is 2. I rise 11, I run 2. Okay. Now what I want to do is I want to use the slope formula so I don't have to draw a picture every time. So I'm going to put my 4 places that I was talking about. Remember, this is y2, y1, x2, x1. Okay, that's the formula I have here. And I need to label those, okay, in my actual coordinates here. So I'm going to call this x1, y1, x2, y2. And it really doesn't matter which one you call x1 and y1 or x2, y2. What really matters are the 2's go together and the 1's go together. So you could have called this x2, y2 and this x1, y1. It wouldn't have mattered. But looking at this, I'm going to say, okay, I have -4 and 7. And then I have -6 and -4. All right. So now -4 minus 7 is -11. And -6 minus -4, well, 2 negatives make a positive there. So -6 plus 4 is -2. And -11 over -2 is 11 over 2. 2 negatives cancel. And that is the exact same thing we got right there. Okay. So I'm going to just use the equation on all these, okay, or use the slope formula rather than actually going through and drawing a picture. So I'm going to label x1, y1, x2, y2. I'm going to put my 4 places, and I'm going to plug in my pieces. Now, last time I did 16 minus 8, and I put the top in, but another way I've seen it done is, notice your y2 and your x2 are above each other, so I could say 16 over 9 and 8 over 20. And 16 over 8, or 16 minus 8, excuse me, is 8. And 9 minus 20 is -11. So my slope is -8/11. And it doesn't matter where you put that negative sign. So if you write it out like this to begin with, it just saves you a little time. Okay? x1, y1, x2, y2, 8 over 17, or 8 minus -13, 17 minus 17. Well, there's 2 negatives make a plus, so that gives me 8 plus, that's a 13 there. Okay, so let's make that a little more clear, huh? So 8 plus 13 is 21, and it's over 0, right? 17 minus 17. Well, 21 divided by 0, or 0 is under the fraction bar, that is undefined. And you want to make sure you label that as undefined. You know it means undefined. Versus, say, like one where we'd have this one here. Three over 10, 3 over 9, 3 minus 3 is 0, 9 minus 10 is -1, times the zeros over the fraction bar, that means it has a slope of 0. All right, well, let's see what else we've got here. Finding the slope and the y-intercept given an equation. And remember, slope-intercept form is y equals mx plus b. So really, we're looking for m and b. Okay, so I'm just going to write y equals mx plus b above each of these and try to match up my pieces. So y equals m and plus b. Well, notice on this one, the m, it's attached to the x. M is 3/2. Sets up really well. Well, b, this says plus b, and this says -1. So really, b is just -1. It's replacing that plus b there. All right, so when I write it in this one, y equals, notice y is by itself, so as long as x is next, it's in slope-intercept form, mx plus b. Well, b looks pretty easy. B there is 3. M looks a little more difficult. There's nothing there. So when there's nothing there, that's just a 1. Don't put 0, otherwise x disappears. So it's a slope of 1. Okay, notice I'm not including x in my slopes. It's just the number, the coefficient in front of x. So y equals mx plus b. Y equals mx plus b. So b is 4. M is negative. Well, negative what? If we don't see a number, remember, the number is 1. Okay, so negative 1. All right. Oh, y equals again mx plus b. Well, notice there's no x in this one. So another way to write this equation is y equals no x's plus my constant of 5. So no x's means that m is 0 and b is 5. And we know that 5 isn't the m because it's not attached to x. Okay, and this last one here, notice it's not in y equals form. Okay, frown on that. All right, so we'd actually have to get it in slope-intercept form. So I want to get y by itself. Oops, sorry about that. So I'm going to go ahead and move that 5x over. All right, that's going to give me 0. Negative 2y equals negative 5x. And that's a positive 4. Notice I don't put 4 minus 5x because it's mx plus b. So the x will come before the number without a variable. And then I've got to divide everything by that negative 2. I'm going to divide everything by negative 2. So it cancels there. I'm left with y equals, but a negative divided by negative is positive. So positive 5 halves x. And we're going to leave it as a fraction because we use slope that way as rise and run. And then 4 divided by negative 2 is negative 2. Right, so m equals 5 halves and b equals negative 2. Okay. Well, the last piece is why we actually use slope-intercept form. So we can actually graph these. So I'm going to take a look at this one. Notice it's not in y equals mx plus b. So we need to get there. So first thing, once again, I'm going to move that 3x over. I'm going to do the opposite by adding 3x. Okay, so that's going to give me a 0 here. 2y equals 3x minus 2. Then I'm going to divide by the 2, and I'm dividing everything by 2, so I'm just left with y. So y equals 3 halves x, and 2 divided by 2 is 1, so minus 1 there. Okay, so that means m is 3 halves, and b is negative 1. I'm just going to write those down, and b tells me my starting point. Okay, so I'm going to start at negative 1. And from there, I'm going to rise 3 and run 2. So from my starting point, in fact, I'll circle it. I'm going to rise 3, 1, 2, 3, and run 2. Rise 3 and run 2. Rise 3, run 2, and rise 3, bit off the graph, run 2. And then now that I see the trend, I can actually go backwards, go down 3, but to the left 2. And there is our line. Okay, notice it's a positive slope, crosses at negative 1, just like we want. Positive slope, crossing at negative 1. Rise 3, run 2. All right, let's change colors here. Okay, so y equals 7. Well, notice this is one again where you have y equals 0x plus 7. So you have the m of 0, 0. and a b of 7. So you're going to cross the y-axis at 7. It has a 0 slope, meaning it just keeps going as a flat line across the line y equals 7. So notice in this equation, y equals 7, it only has one variable, y, and it only crosses the y-axis. Notice in this first equation, it had a y and an x, and it crossed both the x and y-axis. Well, that means like in this last equation here, I'm looking at this last equation, it has x equals -4. So I'm going to go to -4 on the x-axis. And since it only has an x, that means it crosses only the x-axis at -4. Will not cross another axis. And so that is your undefined slope. Notice you don't have a y at all. At least in the 0 slope, you can see the 0x. And undefined, you don't see any y. All right. Well, that's about all I got for you. Good lucky.